hopefully. Oh, there's Pam. Hi.
Hi,
Hi, how are you
everybody.
doing? Hello.
Nation.
Thanks for joining us.
Aw.
So per Pam's request, today I'm starting talking about sleep, and I'm hoping that I would finish it next week. It would not be 1 week, but it's very interesting. Thanks for the suggestion. So, as you know, sleep plays a major role in our health. And when we say a healthy sleep, it has two components. One is the number of hours that you get at night, and that is the most important point. Because unless you're a shift worker that completely has reversed the cycle of being awake and being asleep, and they have to follow certain guidelines, including they have to be exposed to a lot of light during their night shift. So they're basically fooling their body that it's not night stay. And then during the day, they have to go to sleep at a certain time every day. They have to create a room for themselves that is completely dark and there's no noise. So they're again fooling their body that now it's night. So if they continue this regular pattern, their bodies adjust. But many night workers don't do that, and they may take a nap in the afternoon. And what I learned during this research was that nap does not compensate. And no matter how many hours of nap you get during the day, it will not compensate for the number of hours you have lost at night. Another interesting term that was frightening to me, somebody who had dealt with insomnia for 30 years, is a term called sleep debt. And that means that the hours of sleep that you have lost, you owe it to your body. You cannot compensate for that. You have a sleep debt. So the number of hours for adults, it should be about 7 to 8 hours of sleep at night. But the number of hours itself is not the only factor for measuring a good night of sleep. The other factor is that, as we would get into it, there are different stages of sleep. Some of them are REM, which is rapid eye movement. That is when we dream and all of that. And then we have 3 other stages that are non-REM, non-rapid eye movement. And we cycle through these stages 3 to 5 times through the night. And it has been shown that we need both REM and non-REM sleep to have a healthy sleep. Because at each stage of sleep, there are certain functions that are happening in our body. So if we don't get all the stages, then we are not having a good night of sleep. That happens, for example, in pregnant women. Pregnant women have a lot of there's an imbalance between REM and non-REM. And because of that, their sleep is not generally considered a healthy sleep. So we have 2 types of sleep disorder in one categorization, and that is if you're sleeping less than 7 to 8 hours per night, you're considered to be sleep deficient. But if you cannot sleep at night, like many years I could not, like I would just literally go to bed awake and come out of bed awake all night. That is called sleep deprivation, which is obviously worse than sleep deficiency. So when sleep deficiency or deprivation happens, we would start having problems with learning, focusing, reacting to our environment, making decisions, solving problems, remembering things, controlling our emotions and behavior, and coping with change. And therefore, it would take us longer to finish tasks, and we are slower in reaction time. And a combination of these two is a great recipe for making more mistakes. So when we're sleep deprived and sleep deficient, we make more mistakes. Memory consolidation requires both REM and non-REM sleep. So anything that we are learning throughout the day, the brain is wiring those, creating new neuron pathways, consolidating what you learned during that day when you're asleep. And if you don't get enough sleep, that consolidation doesn't happen. And over time, you realize that you can't learn things as easily that you could when you were sleeping better. To give you an idea about how bad this problem is, at least in the United States, I don't have statistics on Europe and Australia, but 50 to 70 million people in the United States have chronic ongoing sleep disorder. And about 7 to 19% of adults report not getting enough sleep every day. About 40% of adults report falling asleep during the day, at least once a month, when they don't intend to sleep. So they're so sleep deprived that during the day they fall asleep. There's a phenomenon called microsleep, which is not something that you can see or notice that somebody is falling asleep, because they're very, very short period of times that you cannot detect by just watching the person. But somebody who is sleep deprived or sleep deficient has these episodes of microsleep throughout the day that they're basically tuning out. They're like very short period of times that they don't have attention or focus on whatever they're doing. What is really, really frightening is that sleep deficiency can be as bad or worse than being drunk when it comes to driving. And it is estimated that sleepiness of drivers is a factor in about 100,000 accidents each year, and 1,500 people die as a result of sleepiness of the driver. So we're going to get a little bit more into different stages of sleep. So when we start falling asleep or preparing to get to sleep, stage 1 happens, which is a non-REM sleep stage. And it's a transition from wakefulness to sleep. It takes about several minutes of relatively light sleep. That is when your heartbeat, your breathing, your eye movements start slowing down and your muscles start relaxing, but you might have occasional twitches of your muscles. And your brain waves obviously start changing, which I'm going to get into the details of brain waves later. Stage 2 is also a non-REM sleep. It is a period of light sleep before you fall into a deeper sleep. Your heartbeat and your breathing continues to slow down, and your muscles get even more relaxed. And you spend more of your repeated sleep cycles in stage 2 than any other stage during the night. So it's not like that you go from stage 1 to 4 just all straightforward. You go to stage 1 to 4, then you go back to, depending on how quality of your sleep is, you may go back to 2 and then go deep. So it just continues to cycle through these stages. Stage 3 is very important because that is stage that determine how fresh you feel next day. And that is the first time that as your sleep is getting deeper, it becomes difficult to wake you up. So your sleep is deep enough that it becomes a little bit difficult to wake you up. And It usually happens during the first half of the night, or so. If you're sleeping for 8 hours, it happens in the first 4 hours after you have gone to bed. Then we get to REM sleep, which is rapid eye movement, very different stage of sleep. It happens about 90 minutes after falling asleep. Your eyes start rapidly moving side to side behind your closed eyelids. Your heart rate, breathing, they all start going up, and they reach levels very similar to wakefulness. But what happens with your muscles at this stage of sleep is that you would become temporarily paralyzed. And the reason for that is that it wants to prevent you from acting out your dreams, because when you're in REM sleep and you're having all those images or dreaming of something, to you and to your body, it sounds very real. It's just like you're awakened to something. And if your muscles are not temporarily paralyzed, you may act out your dreams. So that's the purpose of that. Unfortunately or fortunately, I don't know, it just the normal happens that as you age, the less of your sleep would be spent in REM sleep. So usually infants and newborns have the highest, they spend the highest, they have the longest period of REM sleep. But as we get older, duration of REM sleep kind of drops. So talking about different brain waves, I don't know if you have ever had a sleep study. I have. And so when you do a sleep study, they put some electrodes on your head, check your breathing and your pulse and your blood pressure. And what these electrodes on your head are doing, they're getting what is called an electroencephalogram, which is basically documenting or recording change of your brain waves as you are in the sleep study suite. So they want to see, how much of time you're spending in what stage, and basically they're documenting the quality of your sleep. So going from very high vibration to very low vibration brain waves, the highest vibration brain waves are called gamma. And they are somewhere between 30 to 100 hertz. And they happen in a state of heightened perception, learning, problem solving, and cognitive processing. So the other thing that happens in very deep meditations and states of spontaneous healing, they also happen when your brain waves are in gamma. Beta is a little bit less frequency, something between 13 to 32 hertz. And beta is the brain waves when we're awake. So we're awake, we're alert, we're conscious, we may be thinking, we may get excited, reacting to our environment. And the next stage or type of brainwave, which is now a little bit lower in frequency, somewhere between 8 to 13, that is called alpha. And alpha brainwaves are happening when you're physically and mentally relaxed. So you don't have to be asleep to get into alpha brainwaves. You can be sitting there just relaxing mentally and physically, and your brainwaves drop into alpha. The next brainwaves, which is now even slower, the frequencies between 4 to 8 hertz, they are called theta. And they happen during periods of creativity, having insight in something, deep states, dreams, meditation, and when generally your consciousness is reduced. So you go into theta waves. That happens a lot during meditation, deep meditations. And finally, delta, which is the lowest frequency brain wave, somewhere between 0.5 to 4 hertz. that is what is corresponding to a deep but dreamless sleep. Because if you're at REM, your frequencies approach to frequency of beta because your body is full to believe that you're awake and you're doing something. So your brainwaves go up during REM sleep. But in non-REM, deep, dreamless sleep, you are in delta. Now, I want to talk about what really controls our sleep cycles and everything. And that is, I'm sure you have heard about it, circadian rhythm. Circadian rhythm is an internal body clock that it's basically housed in our brain, a part of a brain that responds to environmental clues such as light, most importantly light, and then communicates with the internal clocks of each organ. So not only our entire body as a whole has an internal clock, every organ has an internal clock. And in addition to that, every cell in our body contains its own clock. And generally in a normal state, all of these clocks are synced together. And that maintains a biological balance in our body. So one of the ways that obviously the brain functions is that when it gets dark, it secretes a hormone called melatonin. And when we wake up, when light goes through our eyes, then the brain starts secreting serotonin and cortisol, things that it is needed for the wakefulness. Circadian clock, different components of it influence cell growth, cell damage repair in an autonomous manner. And sleep in general, and we'll get into more details of it next week as how it relates to different diseases, including cancer. It promotes inflammatory homeostasis, meaning that it decreases inflammation in our body. The purpose of that is that, at night, the inflammation subsides through different mechanisms, through secretion of something called cytokines, and very complicated situation. But anyhow, so what part of brain is playing this role is our hypothalamus. Again, hypothalamus and suprachiasmatic nucleus are the two locations in the brain that have clusters of thousands of cells that receive information as a result of exposure to light or to darkness. And the pineal gland receives signals from these two locations and then produces hormones such as melatonin and serotonin and things like that. The basal forebrain, which is front of brain, like kind of at the base of the brain, also participates in wakefulness and sleep. The midbrain, on the other hand, is what controls our arousal system. There's a compound called adenosine, which is produced and used as a form of energy in our cells. And adenosine secretion or production seems to be a factor linked to a drive for sleeping. And while you're sleeping, then your body starts breaking down adenosine. Caffeine, for example, the reason that caffeine can interfere with sleep is that caffeine counteracts sleepiness by blocking the actions of adenosine. There's also another factor called Gaba, which brainstem and the sleep-promoting cells in the hypothalamus and brainstem produce it. And they act to reduce the activity of midbrain, which is the arousal part of the brain, and prepare us for getting to sleep. Brainstem also plays a special role in rapid eye movement sleep and sends signals to paralyze muscles, so we don't act out our dreams. Amygdala, which is an almond-shaped structure in our brain, and its role is processing emotions. It becomes increasingly active during REM sleep. So REM sleep and dreaming during REM stage of sleep helps you process your emotions. During most stages of sleep, a part of brain called thalamus becomes very quiet and kind of tunes you out of external world. But during REM sleep, which again is very similar to feeling that you're awake, the thalamus is very active and is sending the brain cortex or the gray matter in our brain sounds and images that we are seeing in our dreams. So these organs or different parts of brain are creating what is called sleep-awake homeostasis, which keeps track of your need for sleep. So how does the sleep help the body? Deep sleep triggers the body to release the hormone, growth hormone, that promotes normal growth in children and teens. So children and teens that are not getting adequate sleep, they're not getting healthy growth. This hormone also boosts muscle mass and helps repair cells and tissues in children, teens, and also adults. So in order to get repair in our system, again, we do need sleep because this growth hormone helps do that. Sleep also plays a major role in puberty and fertility. The immune system highly relies on sleep to stay healthy. So when we are sleep deprived, our immune system is, and that's very interesting. During COVID, they did a study, look at different factors that affect our resilience towards COVID or immunity towards COVID, and 8 hours of night sleep was a shown factor that, you know, yes, vitamin C and vitamin D and vaccination, all of that is good. But if you're not getting good night of sleep, your immune system towards infections, including COVID, is going to be very poor. During sleep, also, your body is supporting healthy function of your brain in addition to maintaining your physical health. While you're sleeping, your brain is preparing for the next day. It's forming new pathways to help you learn and remember information that you obtained like this day and prepare you for the next. Sleep deficiency also has been linked to depression, to suicide, and generally risk-taking behaviors, because as I said, it affects our behavior and our emotions when we are sleep deprived. And reaction time is slow, but we may become more impulsive in terms of how we act in the world and react to the events in our life. Sleep helps maintain a healthy balance of hormones that make you feel hungry. There are specific hormones such as ghrelin and leptin that play a role when you sleep, and sleep deprived people gain weight because of this imbalance between these hormones. Sleep deficiency also results in higher level of blood sugar, which obviously can result in diabetes. So as I mentioned about inflammation, a prolonged sleep deprivation can lead to chronic, systemic, low-grade inflammation, which, as we discussed in previous sessions, is associated with several serious chronic diseases. Inflammation is very interesting. It really means to be on fire, inflamed. So your body really is on fire, is just so inflamed. And that is the basis of many, many different diseases. Diabetes, atherosclerosis, neurodegenerative diseases. And circadian regulatory system plays a critical role in prevention of cancer, as I said, repair of DNA damage, and also it influences the tumor suppressor gene. We have multiple tumor suppressor genes, but the most important one of them is called P53. And as we discussed perhaps in the first or second lecture about cancer, tumor suppressor genes play a major role in preventing cancer to grow in our body. And if we don't get enough sleep, our tumor suppressor genes are not functioning appropriately. It also affects insulin level, cortisol level, melatonin, and all of the other hormones that I just mentioned. And it can potentially turn our immune system, or our body system turns it into on all the time or off all the time. And because of this imbalance, because on and off is required to create that biological balance in your body, if you're always on or you're always off, then that balance cannot be maintained in your body. So not only sleep disorders may result in getting cancer, they also affect the efficacy of cancer treatments. So somebody who's sleep deprived may not get all the benefit from cancer treatment that somebody who is sleeping well would get. Recently, scientists have started paying attention and doing research on different pathways of circadian rhythm, because these pathways hold the potential for the development of novel strategies for cancer prevention and treatment. I read a study that they worked on a single protein that, regardless of what type of cancer it was, regulation of that protein was helping the cancer to go away. And most of the times in treatment of cancer, like chemotherapy agents and all of that are very specific. So for breast cancer, you get one kind of chemotherapy. For pancreatitis, you get another type. Every cancer is different, even though there are some agents that are shared or different cancers benefit from them. But treatment is really specific to type of cancer. And what was amazing about this discovery about this protein was that it didn't matter what kind of cancer the person had. It was effective all across the board. So with that, I'm going to stop here. Next week, I'm going to get a little bit more specific about what cancers have been proven and have been studied to have a correlation between sleep deprivation and that kind of cancer. But I'm going to, for this week, I'm just going to stop it now and turn this off so I can answer some questions if you have.